Have you ever stopped to think about what's actually happening behind the slot when you feed $1 into a vending machine or a ticket kiosk? We interact with these machines all the time, but we rarely consider the incredible engineering hidden right out of sight. Well, today we're diving into this explainer to unpack a true unsung hero of the industry. We're taking a close look at the operations manual of a real workhorse, the BB20 banknote validator.
Here's how we're going to break this down today. First, we'll officially meet the BV20 validator. Second, we'll go through the BV20 survival guide. Third, we'll look at the power of validation. Fourth, speaking the machine's language. And finally, critical care and cautions. Let's get right into it.
Section 1. Meet the BV20 validator, the ultimate judge of your cache. If you take a look at the blueprint here, you'll immediately notice just how remarkably compact this unit is. It's totally designed to fly under the radar. Running on firmware version 4.00 or higher, this thing is built for practically seamless mechanical installation. It just slides right into most standard vending setups. No massive overhauls needed. It just sits there, quietly packing a ton of advanced tech into a really tiny footprint. And don't let that small size fool you. This little powerhouse can actually process and accept up to 16 different note denominations all at the exact same time. Now, it does arrive from the factory preset for at least one currency, so you can get up and running right away. But keep in mind, unlocking that massive 16 denomination capacity requires running the validator in its serial control mode. It really is a high-speed, highly intelligent sorting system.
Moving on to Section 2, the BV20 Survival Guide, Enduring Extreme Environments.
Because these machines definitely don't live in cozy offices, right? The BV20 is explicitly engineered to survive some pretty brutal temperature swings. We're talking flawless operation from a bone-chilling 3 degrees Celsius all the way up to a sweltering 50 degrees. So whether it's freezing at a winter train station or baking inside a glass front machine in the dead of summer, it's got to keep reading your bills perfectly.
But it's not just about the heat, is it? It's the moisture. Amazingly, this unit can withstand a maximum of 95% non-condensing humidity. Honestly, that is a wildly demanding environment for sensitive electronics. It proves this hardware can handle practically any muggy, damp location you can throw at it, all without short-circuiting its delicate internal sensors. That being said, even this tough little machine has its breaking point, especially when it comes to power. The manual makes it very clear. If its standard 12-volt DC input drops below 11.5 volts, the validator basically goes on strike. It might start acting up, and eventually it'll just flat out reject your notes. And to let you know conditions are wrong, it'll actually flash its front bezel lights at you. It's basically a built-in SOS, telling the operator, hey, I don't have the juice to guarantee a secure scan right now.
Which brings us to Section 3, the power of validation, an electrical sprint.
So what does this thing actually eat to do its job? We'll check out the massive jump in current it needs. When it's resting in sleep or low power mode, it's barely sipping power, just 1.2 milliamps. When it wakes up into standby mode to wait for a customer, it jumps to 150 milliamps. But the exact second you insert a bill, boom, it goes into an all-out electrical sprint, drawing a peak of 540 milliamps to validate your cache in real time. In fact, the manufacturer strongly recommends using a power supply that can push at least 1.7 amps just to handle everything smoothly. It absolutely needs that intense, sudden burst of energy to instantaneously power its drive motors and optical sensors.
All right, Section 4, Speaking the Machine's Language, Protocols and Interfaces.
Now, to actually talk to the vending machine, the BB20 uses a 16-pin connector on its side, and man, is it fluent. It can output in a whole bunch of standard industry protocols. We're talking SSP, or Smiley Secure Protocol, Pulse, Parallel, Binary, CC-Talk, SIO, and MDB. This massive array of communication options is literally what makes it so versatile across so many completely different types of hardware.
But hey, quick word of warning for any technicians out there looking to upgrade older machines. While the BV20 is perfectly pin-for-pin compatible with the NV7, 8, 9, and 10 series validators, it flat out will not work as a direct pin swap for the older NV2, 3, 4, 4X, or 5 series. No way. Plus, because of different note cycle times, you might run into timing differences compared to those NV products. You absolutely have to know exactly what you're replacing before you go plugging things in.
And finally, Section 5, Critical Care and Cautions, or How to Ruin a Validator.
Right out of the gate in the manual, the manufacturer, Innovative Technology, establishes some incredibly high stakes. They assume literally zero responsibility for errors, omissions, or damages. They make it crystal clear, this is a highly precise piece of equipment, and if you mishandle it, that disaster is entirely on you.
So how do we avoid disaster? You've got to follow their strict maintenance rules to a T. Always use a 2-amp fuse. Never attempt to lubricate the mechanisms. Seriously, adding oil will completely ruin the transport system. Also, absolutely resist the urge to polish that carefully calibrated optical lens. Oh, and if you ever take the unit apart for any reason, you have to completely recalibrate and reinitialize the whole shebang once you put it back together.
So what's the big takeaway from this explainer? It's just how wildly complex the seemingly simple act of inserting a banknote actually is. The next time you slide a bill into a machine for a quick snack or a train ticket, I hope you think about the intense environmental limits, the massive electrical power spikes, and the delicate optics working quietly behind the scenes to verify your cash in mere milliseconds. It really makes you wonder, next time you feed a machine, will you realize just how much engineering is judging your money?